Hello everyone, a happy new year. I recommend a little bit of Christmas cake with maybe a nice cup of tea to wash it down as we do our first lesson of the week, which is going to be our statistics lesson. There will be 4 lessons altogether this week, 3 pure lessons. Let you off 1 lesson given that Monday was a write-off. Okay, so we'll get stuck straight into the statistics and then go on from there. I will also put out some information later in the week to help you with regards to exactly what to revise for the mocks, which are coming up towards the end of the month. Hopefully everything will being well in school.
Right, here's our first example. Pause it and have a look at it and see if you can work out what's going on for yourself. I know it's been a while since we did the normal variable, we've had Christmas and all of that, but see where you can get in terms of working things out, what you might draw, and then roll the video again and see where we go from there. So the first thing to do whenever you've got anything to do with the normal distribution, which we know it is because it's got the n there, is to start with a sketch. And if it's a binomial distribution as well, always start with a sketch. So there's our bell curve, sort of symmetrical, and we know that the mean, which is always going to be called 0 for the normal, so we can't just say that it's 0 because the real mean isn't 0. And they're telling us that the probability that x is bigger than 20 is 0.2. Now, as that's less than a half, that means that we are talking about moving off towards the right, because that shaded area there is a 0.2 probability. And what we want to know is how many standard deviations from the mean that is, first of all. When I say that, of course, I mean 20, because we know that that is 20 as far as x is concerned, but we call the value z once it's into the normal distribution. So in order to find out what z is, how many standard distributions away from the mean it is, we need to take away the mean from that value of 20 and then divide that by the standard deviation. Now the standard deviation is 3. And if we do all of that, we get z. Now, how do I work out z? And that's where the calculator comes in, because we've got to work backwards here. So that's why if we go into statistics mode, we are looking for distribution, normal, and then if you go for the inverse normal, first thing it asks is tail, left or right. So I want it to have an area of 0.2 to the right here. So if I go right and then, oops, exit, right, then go down, change that to 0.2. Now because it's normal distribution, that means that the standard deviation should be 1, shouldn't it? And the mean should be 0. Now, if I press equals there, I get 0.84. So my z value is 0.8416212, and what that means is it is that many standard deviations above the mean. Now I can work backwards from knowing that. So I know that 20 is going to be 0.84162. So if I change if I replace that with my 0.8416, and if I multiply 0.8416 by 3, and then take 20 as well, so into your calculator, if you do, and then we take 20, we would get that the minus value of the mean, let's chuck that into the calculator now, we would get the negative value of the mean being minus 17.47, so therefore the mean, if we divide or multiply both sides by -1, will be 17, and that would be 0.5 to 3 significant figures. Okay, there's the first example. We've just got a couple more to have a look at. Next up, we have a normally distributed problem that looks like this. So take your time, write it down, pause it, have a go, and then check in what you're doing. So the first thing to do, of course, is to begin to make sense of the whole thing by drawing what we've got here. So they're saying that 50 is the mean. Oh, that's not very well done, is it? I'll sort of try and hoik that in there. We know that the chance of it being less than 46, so 46 is less than 50, and the chance of it being less than that is 0.2119. That's that bit in there, and we need to find out what the standard deviation is. So how many standard deviations is it from there? Now that is our x value, isn't it? And our z value is what we call it when it's normally done. So our z is going to be 46 take our mean of 50 divided by our standard deviation. But we need to find out what that z is before we can work out how many what the standard deviation is. So if I go back to stats mode, statistics, and we go distribution, normal, inverse. So we've got a left tail, we have got an area of 0.2119. Because it's normally distributed, we've got a standard deviation of 1, and we're saying that our mean would be 0, and that's giving us an inverse x. So this is giving us our value of this as being negative 0.799846, which would round up to 0 minus 0.80. So what we know is that minus 0.80 is equal to -4 over our standard deviation. So if I multiply by the standard deviation, divide by that, cross those over, we get that the standard deviation is going to be -4 over -0.8, which is 5. So that's our standard deviation. Now to find the 90th percentile of the widths, we're looking here to think, yeah, we know that 50 is where we're at. We're looking for the 90th percentile, so it'll be 10% up there, 90% down here. So that means we've got a left tail again. What else have we got? We know the standard deviation is 5. We also know that the mean is 50, and that's all we need to go to our calculator. Go back here, we keep it as left. We want our probability to be 0.9, so that's our area. our standard deviation is now 5. 50 is our mean, and so that is giving us our value of, I think it was our 90th percentile is going to be 56.4 centimeters to 3 significant figures. 56.4 centimeters, sorry. Okay, and that is the end of the second example. We've got one more example to come up, then you can do some practice. Right, so here's our final example. We've got a random variable. We do not know the standard deviation. We do not know the mean. We know about the probability of it being more than a certain amount and less than a certain amount. Pause the video, draw a sketch, see how far you can get, and then we'll take it from there. Right, so we know we're going to need a bell curve. We know that the probability it's more than 35 is 0.025. So 35 must be right up here somewhere. And there's our 0.025 going in there. We also know that less than 15 is 0.14, so down here somewhere is 0.1469. That's 15. Now what we need to find is the z values here and the z value here. The reason for that is that z value tells us how many standard deviations we are away from the mean for both ones. That's going to allow us to set up simultaneous equations. So one step at a time, get the calculator, and we're looking at inverse normal once again. So what do we know? If we do this one first, we want the left tail, so we've got that already. We want the area, the probability to be 0.1469. We're going for standard normal distribution, aren't we? So standard normal distribution, so that means standardized has got to be 1 for the standard deviation and 0 for the mean. Press equals on that, gives us minus 1.04. Now, 3 significant figures will be close enough for this. So if we say that's 1.05, then I go back, and this time we want the right tail. And, oh, didn't mean to do that. And we want 0.025, standard deviation and mean are already set. And that's giving us 1.9599, which is near enough to 1.96. So that's how many standard deviations from the mean both are. So now let's set that up. So we can say that if you added 1.96 standard deviations to the mean, we would get 35. And here, if you had the mean and you took 1.05 standard deviations from it, you would get 15. Now, as we've got plus the the mean there and plus the mean there, if we subtract the bottom equation from the top, 35 take 15 is 20. Mean take the mean is nothing. 1.96 take negative 1.05 is going to be, forgive me for using the calculator here, that's going to be 1.96 plus 1.05, which is 3.01 standard deviations. So my standard deviation must be 20 over 3.01, 20 divided by 3.01, which is 6.64 to 3 significant figures. So that is that part of our problem done. And then all we have to do is pop this back into either one of these to get where we want to be. So 1.96 times 6.64 is 35. So if I do 35, take that in my calculator, in fact I can do that all in one go, if I take 1.96 times, that's the last thing that was in there, so if I put answer, sorry, 1.96 times 6.64, that gives us 21.97, so that is 22.0 to 3 significant figures. And that's the question answered. Now, I've got to admit, it is a little bit tricky. The key to the whole of this topic is thinking how many standard deviations from the mean, and use your calculator to do the inverse normal to find out what that value is. Once you've got there, you're just thinking it's that many standard deviations from the mean to get whichever value I want. Now we're going to need to do a bit of practice on this. So if you go to page 51 in the textbook, exercise 3E, and have a go at question 1 and 2, just to get you into the basic juices of doing what finding these values. And then for some exam style practice, questions 11, 12, 13 and 14, as many of those as you can get done, and then you should be on top of that. All right, brilliant stuff. See you tomorrow, folks. Goodbye.